Good afternoon, sir. I am Babishamili Daravath. I'm a PG scholar in Vienna Vijayati College, Hyderabad. I would like to present my research entitled with an embedded system for classification of sleep disorder. These are all the contents I'm going to explain briefly. And as we know that sleep is an essential part and it is a major role in every living beings and human lives. And at that moment, I can say that whenever a person is feeling uncomfort or dissatisfied with the sleep, or there is a discontinuity in the sleep, at that time we can say that sleep as a sleep disorder. I mainly focused on these two types of disorders, which is named as obstructive sleep apnea as well as central sleep apnea. These two disorders are the major disorders in overall sleep disorders. So actually, what does this obstructive sleep apnea means? The name itself explains tells us that there is an obstruction in breathing. Clearly I can say that when a person is sleeping, he faces some discontinuity or some interruptions in breathing while sleep, and there will be a blockage of the upper airway. And we can also say that the muscles which is present around our neck, or we can say around our throat, are in the relaxed position, and it blocks the air during the sleep, which leads us to which leads a person who is suffering with apnea to pause his breath. And how we are going to identify these obstructive apnea means the person who starts snoring continuously, and he will make some choking and gasping sounds, and he also feels some daytime sleepiness, and he face a morning headache, and there may be some mood changes. Well, central sleep apnea is also same as obstructive apnea, but the major difference is that here brain fails to send the proper signals to the muscles, which controls the breathing during the sleep. Here we can, in a simple manner, I can say that the person who is suffering with central sleep apnea faces there is a stop and start feeling of a breathing repeatedly. So due to this lack of respiratory effects like obstruction, he faces the central sleep apnea. How we can say that the person is with an central sleep apnea means while he's sleeping, he feels a discontinuity as well as there is a pause in breathing, and excess daytime sleepiness, and concentration may loss, and he'll changes his mood. This is a small introduction about the sleep disorders. The main aim of my research is to classify sleep disorder from the ECG signal by using GRU, LSTM, and BILSTM models. The main objective of our research is to collect the data from MIT-BIH polysomnography dataset, and to pre-process the collected ECG signals, and to develop the deep learning models named GRU, LSTM, and BILSTM. And after developing the model, to verify the overall performance of the developed models, and finally the developed model which is optimized, and these optimized model is deployed into the Jetson nano developer kit. A literature survey, why we are doing literature survey means in order to explore some current states of research, and to identify latest trends and the gaps in the we have been reviewed many studies and focused on the major theme, such as like on a sleep disorder by using the different methods like LSTM, LSTM CNN, neural networks, deep learning model. We have did many literature surveys, but out of which I took the uh, mm, major researches which I have found. I have gave you in a table format. And quickly, I can say that in every human's life there will be a sleep cycle. Not only the person who is suffering with an sleep apnea, but every person will faces these situations, like in a stage one, when a person tries to sleep, he can't sleep directly, and he maybe not all persons, but 90% of the people face these issues. The first 5 to 10 minutes, the person who is trying to sleep will feel some drowsiness, and later he feels he'll move to the light sleep. Later he loses his some consciousness, and quickly he moves into the deep sleep. Deep sleep is nothing but the dreaming stage. The person who is dreaming, we can say that the person is sleeping very deeply, and there are some moments in our body, so that is called as a rapid eye moment. And The figure 2 here shows the cycle of obstructive sleep apnea. Actually, it is same as a central sleep apnea also. How the cycle occurs means whenever the person is sleeping, suddenly the airway collapses and breathing suddenly stops. So whenever the breath is stopped, his sleep is disturbed. After sleep is disturbing, a person starts snoring. Snoring is nothing but whenever the air pauses, he makes some noises. It's called as snoring. So these are all the three disorders. These are all the two main disorders which I have considered in this research: obstructive apnea and central sleep apnea, and one more, that is a normal. That means without any disorders. This is the overall record which I have been collected from the MIT-BIH polysomnography data. Overall 2,700 samples of ECG signals I have been collected from the polysomnography data, which is clearly mentioned here. And the percentage which we considered for training, testing, and validation is a 7:2:1 ratio. That means 70% for training, 10% for validation, and 20% for testing out of 2,700 samples. The methodology which I have been used here is first I collected all the ECG samples or data from the MIT-BIH polysomnography database, which is available in the PhysioNet. Why only for polysomnography means polysomnography is a gold standard which is used to study the sleep disorders. Here the data which is present in this polysomnography data is it is a record of a person who is under the experiment or who is under the study throughout the night. A person went through this experiment throughout the night. From there, these all the data has been collected. Overall 18 records are there in this. And here from these data, I have collected the 30 seconds epochs of ECG signals. While collecting these ECG signals, we may face some issues. At that time, we need to do the segmentations in order to divide, separate disorders. And late after doing segmentation, we need to do the normalization. Why? Because some noises will be there in the ECG sample. So, in order to remove that noises, and to collect the proper ECG samples, we need to do the normalization process. After segmentation and normalization has been processed, after the pre-processing has been done, the all the data has been labeled properly. After that, we just developed a model named GRU, LSTM, and by LSTM. After developing a model, we performed training, testing, and validation. After I started training, testing, and validations from the values of from the percentage assigning from a 60, 20, and a 20. From there I have been started and ended to 70, 20, and a 10, because I got the better accuracy here. So what after these three process has been done, the data has been optimized, and the sleep disorders has been detected. Whatever the simulation has been done, overall optimized model is developed into the Jetson nano developer kit. And we did the step by step process and detected the sleep disorders, which is given as obstructive, central, and normal. As I mentioned that I have been used three type of deep learning models, namely gated recurrent unit, long short term memory, and bidirectional long short term memory. Basically, these three models are a type of the RNN. RNN is nothing but the recurrent neural network, which is used for gating units to control the flow of information. GRU is nothing but it is a type of the recurrent neural units which is used to control the flow of information. Here it has some gating techniques such as, like as we see from this figure, there is some reset gate and update gate. Reset gate is nothing but the data which is it will stores the data which is required and deletes which is not required. And update gate is nothing but whatever the information is there, it will give new info decides how the information is to be retained. And activation or these output data are nothing but whatever the new information is generated based on the current input and the previous input, it will state. And here and coming to these LSTM architecture, it is also a type of the RNN design. Especially these three models are used for the sequential data, and here LSTM is incorporated with the some memory cells gating mechanisms to remember some informations for a long term period. And here the architecture of the LSTM states us that like it has some memory cells which is used to store some data in its memory, and having the gates such as like input gate, forget gate, and output gate. Input gate is nothing but whatever the data is given, it takes as an input, and whatever the data is not required, it will discards that data from the memory cell. And output gate decides whatever the information is required from the it will give the information from the cell state that is given as the output. And actually how does it works means it looks to the previous way. Whatever the diagram I gave here, that is actually a proposed architecture. That means whatever the ECG signals have been sampled is given as a input to the 300 hidden units. 300 hidden units will forms the LSTM layer, and which gives its output to the fully connected layer. Fully connected layer is nothing but which predicts the actual output, and the output of this fully layer connector is given to the softmax layer, which is very important term. Is used to classify the multi classes because I took a number of classes like three classes, so I used the softmax layer here. Coming to the BiLSTM, the name itself tell as a bidirectional. Bidirectional in the sense forward and the backward directions. It has two LSTM layer. One is which process the sequence from the beginning to the end, which is called as forward, and another will process the data from end to back. End to forward, that is called as a backward, and it generates the hidden states from each time step, that is from 1 to t in forward and t to 1 in the backward direction. So these are all the deep learning models which have been considered and compared all these three models. As I mentioned that this is the training data. Training data I have considered 70 percentage for three: GRU, LSTM, and BiLSTM. Training is nothing but it is required to teach the model to learn some patterns from the data which we given to it. So that is called as a training from these three diagram. For these three models, I have considered 10 epochs, and from these graphs we can see the how the epochs are fluctuating. So this is what the training simulation results, and this is comes under the testing. It gives the confusion matrix. Confusion matrix is nothing but which is an important tool in deep learning, which is used to evaluate the performances of the classifications. It consists of four major components like true positive, false positive, true negatives, and false negatives. That means they will explains as that true positive is nothing but the correctly predicted as a positive values, where false positive will tell us that the negative classes which are incorrectly classified. These are all comes under these are all can be given in this confusion matrix. Here if we see the confusion matrix of GRU, we can see the number of the misclassification occurred in the obstructive sleep apnea. There are 39 misclassifications, and coming to LSTM, it is as compared to GRU, it gives the better performance here, better confusion matrix without any more misclassifications. And as compared to these GRU and LSTM, by LSTM has number of misclassifications in the normal itself tell that is without disorder. But here if you observe that there are 63 classes which have been misclassified in the wakefulness is nothing but the normal thing. These are all the performance measures of the GRU, LSTM, and the BiLSTM. And if we observe here, accuracy of each model, the accuracy of GRU is 91 percentage, and of LSTM is like 98.51 percentage. And by using the BiLSTM, we got the very less accuracy, that is 86. And whatever the overall information has been implemented till now, that and the simulation and optimized model is deployed into the Jetson nanoboard. Jetson nanobot actually it is nothing but which acts as a small, powerful, and affordable computing path, which is mainly used in AI, machine learning, and deep learning applications. And also, it is developed by the NVIDIA. It is having some various sensors and software frames, and the main features of it is having a GPU, CPU, and storage. And how we are implementing the simulation means, first thing is, first we need to insert the SD card with the jetpack or operating system, and we need to connect all the peripherals to the monitor, and we need to power up the devices. So later we have to install all the libraries which are required for these. And especially hardware cannot this Jetson board cannot understand the high level languages. So in order to convert the high level language into the machine learning language, we are using here a code converter, and the library is a tensor. After deploying all the information into the Jetson nanoboard by using the SD card, we'll see all the results in the monitor. And later we need to optimize, and the test optimization is done by using the fine tuning, by adjusting some gradient descent approaches and optimizers, etc. We need to do in that way. And this is the final result of a hardware implementation, that is we can observe that 98.5185 accuracy, which is exactly same as the simulation results. So we can say that there is a no misclassification or imbalance has been done between the simulation and the hardware. This is the overall accuracy, precision, and sensitivity. And accuracy is nothing but to represent the overall correctness. Precision is nothing but to represent the propagations of true positive classes which is predicted and highlighted. And a recall is the ability of a model to identify all the relevant instances where specificity assesses the proportion of true negatives and among all the negatives. Fi is nothing but it is a mean of precision, and the recall which is used for providing the balances between the two matrices. So as compared to these three models, I have been taken the better accuracy, that is 98.51 by using the LSTM. And the whatever the research I have been implemented, I compared with the existing models. And we can whatever I have been proposed by using proposed model, the accuracy and the performance has been given here perfectly. By using GRU, I got the performance 91.29. By using LSTM, I got the performance around 98.51. And by using by LSTM 86, which is very less as compared to GRU and LSTM. And as compared to LSTM, we got better performance by using the LSTM, and the sleep apnea has been detected very well without any misclassification. So I preferred LSTM, and I took it as a important model to detect the sleep apnea. And finally, I conclude that um, this deep LSTM model has been proposed in order to detect the sleep apnea by using the ECG signals, and especially the data has been concluded from the MIT-BIH polysomnography database. And these are all the segments are annotated with the mentioned in databases, and a proposed model have been deployed into the Jetson. And the overall accuracy is 98.51. And I also concluded that nowadays persons has to take care of their health conscious, and they especially they need to maintain proper life cycle while sleeping, and they should sleep at least 8 hours. This is what finally I conclude. Thank you, and further I'm waiting for any queries whatever you required. Thank you so much.